important one, which is titled, How Can I Undo a Function? And it's going to be covering pages 2 through 4. So by the end of this period, you will be able to discover equations to undo functions, justify strategies, and graph inverse functions as evidenced in the problems. So for question 5.2, a picture of Anita's function machine is shown at right. When she puts 3 into the machine, 7 comes out. When she puts 4 in the machine, 9 comes out. And when she puts -3 in, -5 comes out. Okay, so the first thing they want us to do for part A is to make a table, organize the inputs and outputs from Anita's function machine, and then we're going to explain in words what this machine is doing to the input, bless you, to the input to generate an output. Okay, so the first one she put in was a 3, and out came a 7. So you're going to input the 3, output a 7. Okay. Then it tells us she puts in a 4 and 9 comes out. So you put in a 4 and 9 comes out. And then the last one, she puts in a -3 and -5 comes out. So -3, -5. So what's happening inside that input machine or the function machine? Okay? Whatever you put in and whatever comes out has to be the same for all of them, right? So for this one, it's you want to multiply by 2 and then add 1. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. -3 times 2 would be -6, plus 1 would be -5. Okay, everybody agree on that one? We're all good, okay. So for part B, it says that Anita's function machine suddenly starts working backwards. Okay? It begins pulling the outputs back up into the machine, reversing the machine's process, and returning the original input. So, if 7 is pulled back into the machine, what value do you think will come out of the top? Right? So if it pulls the 7 back up in, it's going to spit out the 3 back up at the top. And part C says, Anita sets up her backwards function machine and enters the other outputs. What would you expect to come out the top if 9 was entered? You would expect the 4, right? And what would you expect to come out the top if -5 is entered? If it pulls up the -5, the -3 is going to come out the top. Okay? So what is happening? It is giving the input for each output. Or you can put it in your own words. It's sucking up the output and spitting the input out the top. However you want to word that in your own words is fine with me. Okay, so our function machine is working backwards. All right? All right, flip over to the top of page. What page is that? 3. All right. Up at the top of page 3, it says, record the inputs and outputs of the backwards function machine in a table. Record the numbers being pulled back in as X and the numbers coming back in out as Y. So now we're going to flip the numbers. On the prior page, we had 3 in the input and 7 on the output. We had 4 in the input and 9 on the output, and so forth. Okay? So this time, they want us to explain in words what Anita's backwards function machine is doing. Okay? So now that it's working backwards, how can we figure out how to get from here to here? What operations would happen?
Well, divide and subtract by 1.
Okay, so you know that you have to do the inverse operations. He said, what you said subtract by 1, right?
Yeah.
Okay, subtract 1 from whatever the number is. And then instead of multiplying by 2, we're going to divide by 2. Okay? Write the equation for Anita's original function machine and for her backwards machine. How are the two functions related? Okay, so the original function machine was 2x plus 1. We multiplied by 2, and we added 1. So what is the backwards function machine going to be? We're going to subtract 1, and then we're going to divide by 2. And then again, they want another explanation. So the explanation is the backwards function is what we call the inverse operations, is the opposite and in the opposite order as the original function. So on the original function, we multiply first, then add. On the backwards, we have to subtract 1, then divide by 2. So not only are they inverse operations, but we have to do them in the opposite order. Okay? If you want to put that in your own words, you can. If you have a way that's going to help you remember that better. Okay? All right, flip over to the top of page 4. On the top of page 4, you're going to do page 4 in your groups of 4. So let's just read through it, and then we'll have you break up into your groups and do page 4 together. So it says the function machine at right uses the function f of x equals the 5x plus 2. If the crank is turned backward, what number should be pulled up into the machine to have a 4 come out of the top? Okay, you're going to write the value down here. You can show your work here or here. And then part B says, Kiko wants to build a new machine that will undo the f of x, what f of x does to an input. What must Kiko's machine do to 17 to undo f of x and return a value of 3? If you have a highlighter, go ahead and highlight the words inverse function. An undo function is called an inverse function and has the notation f inverse of x. Note that the negative 1 is not a negative exponent. It is the mathematical symbol that indicates the inverse function of f of x. Write an equation for f inverse of x, Kiko's undo machine. So they want you to write the undo function here. And we're going to start calling it the inverse function. And then choose a value for x. What strategy can you use? That your equation, f inverse of x, undoes the effects of the original function machine. And then just explain it. When you get to the bottom of page 4, you are done. And you can start working on the review preview. All right. Let's see. Oh, nope.